Innovation and Engineering and Technology Education recipient lecture. The prize, endowed by a genuine gift from the Gordon Foundation, is named in honor of the NAE member Bernard M. Gordon, former chair of Neurologica Corporation. This award recognizes innovative education modalities in curricular design, teaching methods, and technology-enhanced learning that strengthens students' capabilities and inspires them to become engineering leaders. The $500,000 prize is shared equally by the recipients and their university to support the continued development of the award-winning program. In January of this year, the NAE announced the winner of the 14th Gordon Prize to Northwestern University engineering dean and educator and NAE member Julio M. Otino for an educational paradigm that merges analytical, rational left-brain thinking with creative, expansive right-brain thinking to develop engineering leaders. Whole brain engineering, as it's called, a principal guiding strategy for Northwestern University for more than a decade, focuses on integrating the analytical and technical foundation of engineering with creative, design, and divergent thinking through programs that connect to students at both the undergraduate and graduate levels. Under Dr. Otino's leadership, 3 areas are leveraged to develop whole brain engineers: design, entrepreneurship, and leadership and personal development. By augmenting existing programs and developing new ones to complement an already strong technical curriculum, the school provides a better student experience, prepares engineering to have a greater impact and imagine new possibilities, and attracts more students into STEM fields. Engineering collaborates with other schools and programs on the campus, increasing the centrality of engineering within the comprehensive university itself. New courses bring together students not only from many disciplines, but also from partnering institutions, such as the School of the Art Institute of Chicago. Since making whole brain engineering the cornerstone of Northwestern's engineering strategy, the number of women in the school has increased by more than 60%, and engineering enrollments are at an all-time high. This year marks the 20th anniversary of Dr. Otino's election to the NAE. He's been a dedicated and active member serving on NAE and other Academy's committees, and earlier this year, he and his colleagues actually hosted a National Academy of Engineering regional meeting at Northwestern, which you can read about, by the way, in the Bridge this fall. Please welcome to the podium Dr. Julio Otino to present the Gordon Prize Lecture, after which there will be time for some questions from the audience, so please take notes. Welcome, Dr. Julio Otino. Okay, Julio, there you go.
Well, thank you, Chairman England, especially the Awards Committee. I had lots of people to thank, and fortunately I could do that in writing at the Bridge. And my special thanks to Dan Moat. So, in talks like this, I think one explains the what. I don't think everybody here is interested in the how, but I will explain the why, and why now. So, universities are organizations that produce 2 things. There are 2 inputs, human capital and money. And what we produce are ideas, papers, books, concepts, and people. Now, if you are going to think about what to do, which is global, probably it helps to think about what the world is doing now. And there you have a list of things that are taking place now. But the common link in between all of these things is that for at least some people, and I will not pretend that the ideas that I will develop here apply everywhere, for some people there is a great opportunity to operate at intersections. And these intersections, just to start far back, I will kind of sail through lots of things. Some of these things could be entire papers. And if there are questions about that, I will be able, and many of these things probably you know, but I will start when art and science and technology were one, how they separated and how they may yet join again. So, at some point in the past, art, science, and technology were one. And to start with the early Renaissance, you have someone like Filippo Brunelleschi, who was trained as a goldsmith and built Il Duomo in Florence, something that had not been done since the Pantheon in Rome. Not only imagining how it could be built, he also built the machines that could build the Duomo, and in passing, he developed all the rules of perspective that guided visual arts for centuries to come. But at the same time, there were people who were going the other way around. Niccolo Tartaglia, a mathematician, made incursions into cartography, ballistics, and at some point, mathematicians who move into practical issues like diverting rivers change the balance between all the knowledge being associated with the philosophers. Galileo, for example, had to teach Ptolemaic philosophy because the concept of progress, innovation is a good word for us. For a long while, innovation was not a good word. At some point, principalities, republics, starting seeing the value in people like Tartaglia and others, and that changed the balance because money was involved from the philosophers to the mathematicians, and these are the people who actually paved the way for the Industrial Revolution. Now, I have to mention in passing, because many of you have read C.P. Snow, there are 4 lectures, everybody has read lecture number 1, everybody should read 2, 3, and 4. But C.P. Snow, the 2 cultures, is basically about physical sciences and writers. I'm not talking about writers, I'm talking about visual arts in general. So there have been many, many examples over the years of points of confluence between art, science, and technology. I'm going to mention 1 or 2 in passing. There are entire papers written by people who are historians of science, some of these. One of them is the Galileo Harriot story with the craters in the moon, Pasteur and chirality, Bohr, cubism, and then probably something about Poincaré and Duchamp. So the Galileo story is probably the most interesting to mention. Galileo in Florence and Thomas Harriot in England, they both were the first to look at the moon with telescopes. They were built in the Netherlands. Galileo actually built his own, and they both saw the same image. However, Galileo, being in Florence, he was trained in a whole bunch of things that augmented his thinking, and one of those things was l'Accademia del Disegno. Everybody who was an artist, architect, or not in l'Accademia del Disegno had to go through exercises on perspective that are like ones represented in that figure. The Academia had a position for a mathematician. It is rumored that Galileo applied and did not get it, but then he was elected on his strength as an artist. Galileo, whose sketches you see there at the right, this is what he saw about the moon, and Thomas Harriot is at the left. However, Galileo instantly, based on his training in perspective, could identify that the moon was not a perfect celestial object, as it was believed at that point, and there are entire things that will, if there are questions about this, I can explain. He was able to calculate the height of craters in the moon, and that was based on his training in art. The other one is Poincaré, who was actually almost a contemporary of Picasso and Duchamp, but the pictures look like from completely different eras. The most complete mathematician of his time, and someone who, if you were broadly educated, you had to read. There were lots of people who specialized in popularizing Poincaré, and some of those people influenced Picasso and influenced Duchamp. And Duchamp actually mentions Poincaré explicitly in his writings. Then there is Niels Bohr, and Cubism. And Niels Bohr had that painting that you see in his studio. He was treated lavishly by the Danish government. He in Carlsberg House, he had that painting. And that painting was a work of this fellow Metzinger, who was actually one of the ones who wrote a theoretical treatise on Cubism that was the origin of what Poincaré and Duchamp connected with. So Niels Bohr delighted to tell visitors how something could be several things at once, and would use this painting that now is in the Museum of Denmark on how to explain complementarity. Okay? So there have been other attempts, and one of the most valiant and more recent was this journal called Transformation, that was created by someone named Harry Holzer in New York. It lasted for exactly 3 issues. There you are seeing the entire run of the journal. And the manifesto behind this journal was, Transformation affirms that art, science, and technology are interacting components of the total human enterprise. But today they are often treated as they were cultural isolates and mutually antagonistic. So the goal of this journal was to bridge that gap, and he commissioned pieces, and there was an illustrious list of people whose name you can recognize depending on your art, on humanities, or science, but this lasted just 3 years. And then there were attempts like by design, like the Lunar Society of Birmingham, that connected the proto-scientists of the day with the engineers of the day, with entrepreneurs of the day. There were no artists in this group except someone who did a portrait of all of these people together. Now, why they separated? Part of the separation was Galileo himself. Galileo was the one who put physics on a mathematical language, and there is a famous quote on him about the language of the universe being mathematical symbols. And at some point, this structure of mathematical thinking went so far that it started competing with what was sort of coincident with this motion, that was the idea of creativity and genius. So the idea of the first thought being something that emanated from a mind that the concept of genius emerged in the Renaissance, called il primo pensieri, that thing that is in there who probably evolved into some more complicated design that produced eventually this, okay, was the thing that bifurcated the Renaissance and creativity with the mathematical thinking that was the paradigm that followed. And you know all of this, that at some point they reached the point in which someone like Lagrange will declare in the preface of the book that his book had absolutely no figures whatsoever. So the question is, can we merge rationality and creativity again? And the metaphor is the following. And this is a metaphor in the same way that, I don't know, the universe is not a clock and there is no invisible hand telling us what to do with economic decisions. It's a metaphor. As a metaphor, I will ascribe the left rational thinking, convergent, parse, decomposing, systems 2, if you read the book by Kahneman, the right brain, creative, metaphor, divergent, whole, compass, that kind of thing. And there is some grounds for this, but as I said, it's a metaphor. This paper appeared last year in which they examined connections in between the left and the right hemispheres. They did some tests evaluating creativity, and they thought that there were more connections. Something more interesting is this. This fellow, Dean Dellis in San Diego, did experiments with people who had suffered massive brain loss, either right or left. They show an image like this, and they ask, tell me what you saw. And the people who only had the left brain active, they saw this. And the people who had only right brain active saw that. Okay? But I still insist this is a metaphor. So how do you develop this whole brain system that we are talking about? What we needed to do, and this is the part that has to do with more being a manager or a leader, is see ourselves as a part of the system rather than vertically integrated structure. Rethink our core. Part of this is thinking like an artist. When you are in art school, you don't learn theory and then you paint. You start by painting. And then we started investing in targeted collaborations with every part of Northwestern, even if we had to subsidize them because our students will be 1/3 of that component. But then understand how disciplines operate. Now, from now on, I'm going to show lots of slides that I show to the students the first week that they are in class. An audience about this size, probably bigger, 500 people, all the undergrads ready to go, graduate students. So I have to explain how art, science, technology work, especially art. So you have art, science, technology, and if you want to put a verb to each of them, you will say art is creation, technology is invention, science discovery. Except that no artist will put the word creation with art, and I will explain why. And then if you have to put right brain, left brain, you'll do that. And so the way that we go about doing this to start with is with design in the middle, because it spans the two camps. And the way that design is in there is that teaches you something, which is how to uncover the real question behind the perceived question. There is no big prize for solving correctly what turns out to be the wrong question. Okay? And design teaches how to do that. So art, technology, science, very simplistically how they grow. The biggest discovery of science is science itself. Okay? There are no dead branches in science, they get trimmed. Once in a while there is a revolution. Technology, you don't wait for one technology to die, the next one emerges. Art is more like this, now. Okay? So in science, it's a good strategy to start on the shoulders of giants. In technology, the only reason to start on the shoulders of a giant is to crush the older giant. And in art, it's actually a bad idea to stand next to anybody. Okay? Derivative is a very bad word in art. In technology, that's not bad. Technologies are combinations of things. So if I show you all of these paintings are done in between 1890 and 1950 and ask you, put them in chronological order, it will be hard unless you have taken a course on modern art. There are more in there, Jack Close, de Kooning, this, and these two actually were done by the same person. Probably one of the greatest painters alive, Gerhard Richter. So why now? Why now the connection with art? Let me just, in 5 bullets, tell you the history of art, okay? He started in the Renaissance. Is the first time that you start seeing names associated with paintings. Maybe Giotto will be the first, okay? There were apprenticeships. That's how you learn. That's why in museums you see from the workshop of Rubens or the studio of Rembrandt. Then in the 18th and 19th century, breaking the rules became the thing. The artist as a struggling person overcoming all the odds. The lone genius, okay? Breaking from the craft. The emergence of the term fine arts. Then modernism, the time that gave Picasso, Virginia Woolf, and Stravinsky, artists becoming the cultural aristocrats. And then the professionalization of art with the emergence of MFAs. And now artists are entrepreneurs in full force. If they need to learn how to code, they will learn how to code. If they learn how to do something connected with 3D printing, they will learn it. Artists now are entrepreneurs. And art now is a different game than what most people think, because most people's conception of art is connected with the second bullet, the Romantic period. So the entry point for us is a course called Design Thinking and Communications. I did not write this table. The Wall Street came, they stayed with us for about 2 days, and they decided that the people in this course learn the following things. So the course is 2 quarters. They run with the first quarter having simple problems connected with someone real, a client. The client could be someone who comes from the Rehabilitation Institute in Chicago, could be a 10-year-old boy that was born without arms. Until he was 5 or 6, the family will take care of all the things, but now they want to be more independent. So the teams of four, every team will attack the same thing. They will meet with the client after deciding what the question is, and they will propose by decree 3 possibilities in such a way that the clients can say, you know, about possibility A, we like everything, but we don't like this part. Possibility B doesn't really work for us, but we like this component of possibility C. And in learning to do that, they learn all of these things associated. The brains of 18-year-olds are very plastic, and if you do this at the beginning, it marks them for life. The consequence of this is that instead of consume, then produce, there is an aspect of consumption and production together. And then what we have done is create enough things in the ecology of Northwestern that they connect things that they were unthinkable 10 years ago, like in a course having an MBA, a lawyer, and a medical student together with undergrads. So some of those courses are the ones in there. I'll explain the first one, which is the only one that is not free market, Novation Medical. By decree, 2 students from engineering, 2 from the medical school, 2 from the business school, and 2 from law. The students of 8 going to the hospital. They are hosted by a surgeon who, by the way, most surgeons are closet inventors, and they have to uncover something that will represent an innovation in that space. In all of the courses, there is someone who has practiced in that domain. All the other courses have people from sociology, anthropology, you name it, music, all together. But we want to allow for organic growth, and it's what students will do if they could do what they want. So we created this program called Design for America, starting in Northwestern, and then it has migrated to all of these campuses. And these are people who pick problems where design thinking is important, but have some social implications. Now, let me mention a couple of things that I mentioned the first week of classes to the undergrads, and no one bats an eye. And this is lessons from art. Okay, so here you have Matisse with 6 sketches. And here you have the final piece, La Danse, which is in Leningrad. But some days Matisse will show up to the studio. He was not full of creative thoughts. And he will do a painting of a painting. Here is one, here is another one. There are multiple of them. Painting what was in his studio. Lesson, inspiration is overrated, okay? You have to work like hell. And we tend to overrate artists on how inspired they are. They work really, really hard. Picasso did 1 work of art every day and a quarter. Here is Picasso again at 15, 17, 22, 40. Here is Malevich, a Russian constructivist. This is how Malevich started. Then became like this. They became like this. You probably think there is nowhere to go from here. Yes, there is. This. Okay? The lesson. Start with a solid grounding. Learn the craft and then set it aside. Picasso again. This is at the MoMA. Picasso again. This is all with found parts. All objects that he found in his studio. 2 toy cars in there. But once you see this as a whole, you cannot separate the objects. The lesson, bad artists copy, great artists steal. Okay? Copying is try to produce a replica of the iPhone. The iPhone itself is adopting many, many things in a new whole. Another Picasso, this one is at the Art Institute. But the story is this, there was a collector from Chicago, visited Picasso, mentioned that we have this painting, and Picasso said, you know, I remember that, but when I finished painting this, I decided this was not what I wanted to do. So I painted over and I cut the piece that I regarded superfluous. Here you have the piece. The Chicago Art Institute never exposes the 2 pieces together. So there was a man holding a fish that the baby was going to touch. What's the lesson in here? Do not converge too quickly. Step back and look at the entire picture. And most of you can resonate with that. So, but besides whole brain individuals, you have to have a whole brain organization. Organization for me is something that makes judgment and decisions, and presumably it helps you reduce cognitive biases. So I'll bring two lessons in here. One is complementarity, which you all be familiar with, and complexity. I think it's possible to thrive in complementarity. Okay? Yes, light is a wave when it travels, particle when it interacts with matter. I don't think, like in the Niels Bohr conception, we have to pick one side. I think you can be art and science at the same time, creation and analysis, rationality and intuition, abstraction and realism. The problem is not applying one side to the wrong issue. The other one is this. Picasso again, a series of lithographs, and this is the last one. But I went very quickly through this, so probably you couldn't see the dates. In fact, Picasso did it in this order. This was the first, and this is the last. So the lessons are, and this will resonate with many people here, a theory in many respects is in simplicity and complexity. You have multitude of facts, and there is one encapsulating view that condenses all of it. Some people are good at that, but you also have to be able to go the other way around. From one thing to be able to see many things. The last sentence of the paper by Watson and Crick, it has not escaped our attention that the structure proposed can have interesting biological consequences. Wow, that was the understatement of the century, but no one could see all the ramifications from there. So you have to be able to see which one of these you are good at, I tell the students, and train yourself for the other one. The whole brain network that we have created consists of many parts. There are connections with courses with the Art Institute, as Dan Mote mentioned, connections with art theory and practice in our own institute. We have problems of conservation. We have virtually a network that spans every school in Northwestern. But 2 points about this. The entry point is this design thinking and communications, which is at the bottom of this. And the core, which I tell people, this is going to be heavy going, which is the core of engineering, which is non-negotiable. You have to have that. If you have that, and you have the right students, then you can do all the other things. Our objective is to produce people that when they see this, they don't see this, but rather they see this. Thank you. Yes.
Good. I'm supposed to moderate your questions.
Yeah.
Help you, protect you in these questions. So the floor is open for questions from you for Dr. Otino on his program or on his approach to this. Any questions you may have about this? You have some curiosities. I don't know if we have any microphones out here now. Yes, we have a microphone over here and one over there as well. We have a question, Deborah.
Hi, my name is Andy Lovinger. Andy Lovinger, National Science Foundation. Thanks very much for this very interesting lecture. You mentioned tens of names of artists and scientists, and I was surprised not to see among them the one who I think undoubtedly exemplified the integration of brilliant art with brilliant engineering.
Okay, let me guess. Leonardo da Vinci. Yeah. Well, look, I could have mentioned 15 names. I just finished a piece with my colleague, which is the Dean of the Arts and Sciences, who happens to be a historian, specializes in early Renaissance. And we want, I mean, there are 15 names. Some of them not well known. Da Vinci, yeah, is the archetypical example. So, yeah, we could mention that, and we mentioned that in a longer piece. As I said, for everything that I said, you can go much deeper in any component. But Da Vinci is probably the prototypical one. But there were many other ones. If you read more about, for example, this guy Brunelleschi, he was amazing. Alberti was amazing. There are people who are not really household names, but it was the confluence of talent in Florence at that time was amazing. There was one in there.
I am Jan Sengers from the University of Maryland. I thought your lecture was very inspiring, but I have one question which came up. You are talking about integration of art and science. Don't you think we also urgently need integration of religion and science?
Sorry, with what? Integration
of religion and science.
Oh boy. I think I will take a pass on that one.
I think we do.
Thank you very much for a wonderful lecture. My name is Harry Shum. I work at Microsoft. So your lecture really reminds me another aspect, that is the importance of language. Surprisingly, as you talk about arts and the science, you didn't mention about the relationship with language.
Well, there are entire papers about whether or not language and even the symbols in language, in Chinese, for example, influence the way that you think, and even the way that you think of pictures. There are entire papers written about that. I have to talk for about 30 minutes max in here. I squeeze as much as I could. But yeah, that's another aspect to this. If I ever write a book on this, I'll probably put something on that. Yeah.
Hi, my name is Alex Gray. I'm currently an undergraduate at University of Washington. And I'm curious, engineering curriculums are really, really full. And the number of credits involved and the numbers of hours involved, trying to get through in 4 years is difficult and extreme. I'm wondering, how have you figured out how to balance that time tension with trying to have this broadening? I would also be curious if it's possible to have your slides emailed to the group or something to that effect.
They will be in the website, I think of. So you actually allow me to answer two questions at once. One, your question, and the other one from your colleague from NSF in there. As I said at the beginning, I don't pretend that this can work everywhere, okay? We accept one student in 12. Many people have with so many advanced placement credits that they can finish with a bachelor's and a master's in 4 years. Yeah, ABET is in there, and we have a core that is very constrained. But in our case, we can make it work. Some people stay longer. I think the biggest problem is not with the undergrads, it's with the grads. Undergrads in most universities are hired by single brain, so they are all very similar. Graduate students, they are hired by multiple departments, and many like me when I came to this country. They are like a missile trying to do one thing well. And on top of that, you have the accountability of reporting to agencies, effort reporting, the advisors not trying to invest on the short term, and having people in the lab and not let them broaden. And I mean, our job as a university is to have people emerging with what I call the very best but first draft of themselves, okay? And part of this is that they can continue augmenting those drafts. So at the undergraduate level, it works, at least in one case and other places like this. At the graduate level, it's much tougher. But there are always enough people who want to do these kinds of things. And if we do events like having a conversation about creativity, and I bring a philosopher and the fellow who designed the Burj Khalifa, Bill Baker, who is a member of NAE, and a guy who is a writer, and we talk about how do you handle constraints. I get enough public from graduate students to demonstrate that they care about this, but doing it at the level of penetration as undergrads is much more difficult. Yeah.
Joichi, and thank you very, very much for your presentation. It really is a dream come true. I have taught for 50 years in engineering school. I still teach. And what you really are advocating is classical education, which I am a result of. What worries me, sir, is that the current undergraduates, I'm at Berkeley, really feel this tremendous pressure of competitiveness to get the proper jobs, and therefore they select much more skill-given courses rather than broader education. Do you have any advice how we can change it?
I think based on demand, at least in our case, that's not the biggest pressure point. The biggest pressure point that I see for undergrads is, at least in some places, you are the best kid that was produced by a high school in Montana, okay? You are told that you are amazing, and then you show up in some places and you are just like everybody else. And readjusting your thinking and your worth to something that is not tied directly to grades is important. So we have been teaching in parallel with this, I did not mention it in here, many things that have to do with emotional intelligence, courses that we run them, but the number of people from engineering is probably a fourth, but just connecting with other people and thinking about life more in broader terms, planning your life. There is a course whose title I asked permission to Percy Drell, who was the dean of Stanford. It's called Designing Your Life. One interesting thing about these courses is the number of women greatly it's much more than men. Probably men don't think that they need those things. But in time they equilibrate. So I think the pressure on getting jobs, basically with a degree in engineering, I mean, the problem that sometimes many of us have is if 60% of your class end up in consulting or finance, that's too many in my view, but there is nothing that you can do except show examples of where they can go and do things. But but I understand the issue about jobs and just doing everything with one objective in mind, and is to get the dream job. One thing that I noticed, at least with some of our students, is that they may have a job waiting, but it's not the dream job, and they will wait. They will not just take any job. They want what they think is the dream job.
We have time for one more question. This is Deborah.
Yeah.
But before we get started, I need to see a Barry Voigt. We have a Barry Voigt here in the audience. Barry Voigt. Okay. If you could just meet me at the exit at the door here.
Mm-hmm.
Hi, I'm Charles Lyserson from MIT. I wonder if you're aware of the work on whole brain leadership by Ned Herman, and if so, how that relates to what you're doing.
So where is he at?
Well, he's dead now.
No, but where was he? Where was he? What was
he was at General Electric originally. And
where?
He's General Electric.
Yeah, I mean, over the years, I have been sent references from many people, and there's another guy who is still alive who has sent me something on that. Yeah, I have seen some of those things. I mean, the thing that I have been, I have paid attention to all of these things, including all the people in neuroscience, and I talk a lot with them because I care to know that side as well, having some preserving what I'm saying, that I'm not saying everything that I know except having more. No, but I don't know if I know this person. But I have been, over the years, you start doing something like this, everybody sends you something that they think they should know. Yeah.
Well, thank you, Julio. Thank you very much for this. Definitely stimulated a lot of interest. Very much. I just have to tell you one story before I went to Northwestern a couple of years ago. I don't know, 3 or 4 years ago, and I happened to meet with a provost a fellow named Daniel Linzer, who's now left, gone somewhere, and he told me about Julio's the initiative, and he said the following thing to me, which I thought I would never hear in my life. He said to me, and he was a bioscientist, cell biologist. He'd been the faculty member there, dean of arts and sciences, and now he's provost of university. And he said the following thing, just out of nowhere. He said, Northwestern used to be an arts and sciences university with a few other things wrapped around it, you know, the engineering, business school, and so forth. But because of Julio Tino's full brain initiative, it's now been transformed into an engineering university with other things wrapped around it. And because it's brought in the arts, it's brought in the humanities, it's brought in social sciences, it's connected all this to engineering. And even the communities outside, as we described earlier, were brought into this as well. And then subsequently, I went there again, and he was, effusive on this, and even the president said he was working for Julio in his project as well. When we had the announcement of the gift at Northwestern, the president stood up and talked about he's working for Julio, and the provost is working for Julio, and so I think, my gosh, this is nirvana, really. So Julio, congratulations, and your message has been very deeply received in Northwestern. Everybody there is talking about it. So with that, we have time for a break. We have about half an hour, and then we'll come back for the plenaries. We have two plenary lectures left today. So please enjoy yourselves with each other.